Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. G'day, welcome back to the Passive House podcast. I'm Matthew Cutler-Welsh, coming to you from Auckland, New Zealand.
And I'm Zack Semke, coming to you from Seattle, Washington.
And we've got a special component spotlight welcoming back a great supporter of the Everything on the Accelerator, PROSOCO. We've hosted them a number of times in various different formats, and I believe they've been on the podcast before, Zack.
They have indeed, yes. So so this builds on that conversation. We'll put a link to that episode from last year in show notes, so folks can take that in. But we're joined this time by David Boyer, Paul Grahovac, and Pat Downey of PROSOCO. Dave shares a really interesting kind of story about the history of PROSOCO. You know, they've been around for many, many, many decades, which is fun to hear about. And then we talk a little bit about the connection that Pat Downey made between, problematic window installations and the importance of really robust water barrier treatment in window rough openings, and then into the importance of compartmentalization and dealing with things like COVID and the health impacts of good air tightness. So pretty diverse conversation, and I think folks will enjoy it. I'm very excited to have David Boyer, President and CEO of PROSOCO, Paul Grahovac, Technical Manager, Building Envelope at PROSOCO, and Pat Downey, Building Envelope Technical Specialist at PROSOCO, here for a special component podcast episode of the Passive House podcast. It's great to have you here. And also a big thank you to PROSOCO for being a champion sponsor of the Passive House Accelerator. It means a lot to us and helps us do our programming. So David, why don't we start with just a little bit of a primer history on PROSOCO to get things kicked off today?
Well, PROSOCO celebrates 85 years next year, so it'd be a long history. It all started with a buffered acid solution being sold by our grandfather, who was a used car salesman back when used cars was an emerging industry. They were then packaging that buffered acid solution in quart and gallon glass jars and wooden crates. And they got an order from the state of Texas out of the blue for 4 drums of this solution. So they first had to find drums. They bought some wooden staved barrels, lined them with tar, filled them with many, many batches of this buffered acid solution, put it on the back of a truck, and followed the truck to Texas, and found out they were using this solution used to descale radiators in cars to remove hardened Portland cement from the face of brickwork. Texas was in a post-war building boom. They were trying to house all the returning GIs. They needed more mileage out of their mason contractors, and one way to make a mason contractor work faster was to add more Portland cement to his mortar. In doing so, they didn't clean their work as they went, as was traditional prior to that time, and is still in many parts of Europe. But they just laid the brick as quickly as they could, and then brought someone after the fact to remove the hardened Portland cement. They found this solution, which was then dubbed #1 lime solvent and became #101 lime solvent brick cleaner to deal with the post-war building boom. Time passed, color preferences and brick changed, new cleaners came out to clean new brick. More time passed, colored concrete replaced brick in some people's preference, so specialized cleaners were developed for that. And time went on, and more things came in the industry. And Process Solvent Company at that time was the company's name, would try to respond with a purpose-built cleaning solution for different building materials. Protective treatments first came into our lexicon back in the early 1960s. The first product was marketed in 1963. And by the late 60s and early 70s, as the country began preparing for the bicentennial, urban renewal gave way to the building preservation movements, and a line of specialty cleaners for building restoration cleaning began being developed in the central Midwest and gradually expanding out to the east. That gave way to work on more and more prominent buildings where preservation treatments were required. We explored that with European counterparts. And it was when I was traveling through this country, through Canada and Europe, that I first noted another part of the building envelope I'd never until that time seen. They were building the structural assembly. This was on a building adjacent to what is now St. Stephen's Green in Dublin, Ireland. They were building the structural assembly. They were wrapping the structural assembly in what I interpreted as a roofing membrane, creating a cavity and then putting brick veneer around the face of that. About a year later, I saw a similar detail being replicated in the Canadian markets, and then a year after that in New England. And I began studying something they were calling the air barriers, and realized this is an entirely new component of the building. It was going to take some science to understand it, so we did a deep dive on the air barrier requirements at that time, and partnered with another company that was championing air barriers in a different type of construction assembly than masonry. We tag teamed. They went to what was the EIFS industry, and we were targeting the masonry industry. And it was through that partnership that I was introduced to a company called Building Envelope Innovations that had developed a new fiber reinforced fluid joint detailing compound, because we had realized by that time that that was one of the weaknesses in the system we were then marketing. So Paul Grahovac and I traveled down to Florida to meet with people at BEI and the facility they were then occupying in Naples, Florida. And when I first walked into the facility to potentially invest in a formulation, I saw test chambers unlike any I'd seen before. These test chambers were massive in scale to what I had seen at other testing laboratories for the air barrier industry prior to that, but they were more robust than what was typically either a reinforced wood assembly or a reinforced masonry concrete block assembly. These were made out of welded marine-grade aluminum. And I was doing a lot of looking and, well, frankly, gawking at these testing facilities. And I observed that, and I love the ocean and I love ocean-going boats. I go, my God, it looks like it was built like a boat. And I then learned that the builder, Ron Tatley, he said, yeah, I used to build boats.
Oh.
And over the course of a couple of drinks and dinner, he said, when you're in a boat, you want the structure to remain watertight as long as it's intact. Why shouldn't we expect our buildings to perform like that? So when they were developing products to air seal and weatherproof buildings, that was a self-imposed discipline on them to make sure that as long as the structure itself remained intact, they could keep unwanted air from getting in and conditioned air from getting out. And that was truly revolutionary. First time I'd seen that, and still to this day, one of the only companies that I've encountered that had the presence of mind to apply that discipline, not just to their product development, but to the products they were also taking to market. So I walked in there thinking I was going to invest in the formulation, and I said, no, I want a partner. You guys clearly understand this better than others I've dealt with in the industry. I want to learn what you know and build on this together and see if we can take it national. And that's how the relationship between PROSOCO and BEI, Building Envelope Innovations, came to be. We still have the testing chambers that they started with down there in Florida and also in Washington State. They now reside in the building adjacent to PROSOCO's corporate headquarters in Lawrence, Kansas. And we regularly entertain consultants and others that are interested in building pathology and making buildings perform better to see demonstrations that take it up to industry standard performance levels, but also up to structural design loads or failure. And taking systems to failure can be very eye-opening and can help you build systems which are engineered up to current standards, but really engineered to what should be the realistic expectations we have of building performance.
I don't think I've ever heard you tell this story, David, and it's a great one. Thank you for sharing it, and really interesting to hear about this kind of interaction between the building envelope in different layers of the building envelope and chemistry and PROSOCO, since we were putting products in tar lined wood barrels. So it was really, really fantastic. And I know that on maybe the tail end of that story, there's some parallel storytelling that we can hear from Pat, because there's really interesting introduction to this world. And I think it also hits on that, how much we learn from failures. Before
we made the trip to Florida, we did some investigation on the chemistry and found out that this was the type of chemistry commonly used in many phases of the transportation industry to chemically weld dissimilar materials together, metals and plastics, sometimes wood materials, to chemically weld them together to make them watertight and resistant to the seismic impact that over-the-road travel does. Mm. And it occurred to me that if it could do that, the perfect place for that's going to be in the window rough openings, because that's where you've got many disparate materials with different thermal coefficients coming together that had to withstand severe conditions. And that's what made the trip to Florida, and the rest is history. But I'll let Pat tell his perspective, because he was outside of BEI at that time too.
Yeah, you just served up the volleyball for Pat there, I think. So Pat, take it away.
Yeah, back in January 2006, I worked for a window manufacturer based in Canada. I was the project manager in Washington, Oregon. And I've been doing windows since the early 90s. And I'm on this project, and we installed 5 window systems, windows and doors, and I failed 5 out of 6 tests. And that's where the gray hair started. And I'm looking for a better system. Our system was not working. And the window we were distributing for this project came to me and said, hey, because they heard about the failures, and it was the interface of our peel and sticks and our urethane sealants under our pans. And they said, you got to check out this red goo. We used it on Vancouver Island in BC on the West Coast, and we never had a leak. And so I contacted the BEI guys, and they did a dog and pony show for me. I was skeptical because it was brand new, but after they went through everything, they said you were having adhesion issues with everything. Nothing was sticking to the old concrete. And so Tom went up and he says, let's start applying product, because if you're not testing, you're guessing. And so a week later, I called my foreman to do the pull test, and he said, this stuff's sticking like nobody's business. Really good. So I flew people down from Canada to take a look at it, because it was brand new out on the market in 2006. And they finally approved it. We started using it around the rough openings. We actually hired Tatley Grund to apply the products. And basically a light bulb came on saying, my guys can apply this products, or anybody can, in bad weather. And it doesn't take up room in the rough opening like a peel and stick does. And then one of my installers said, hey, it's kind of cool. You put your shims down and they don't move. And then from about the 5th floor of the first tower, there was 3 towers, 20 some stories each. We use this material and we never had a failure. So I became a big fan. In 2008, they hired me away from the window industry, and then I started marketing it in the Northwest, and then brought us down into California. And the rest is history.
Yeah, that's so great. So you mentioned 2006, about 5 years ago, then I was first witnessed our guard on the Karuna house that Hammer and Hand was building, and just struck by the simplicity of application, the way that one product on the surface of the envelope could kind of meld seamlessly into the products that are going on in the rough opening, and the way that system kind of interacts with each other, and it was definitely sticky. There were
I've got a lot of waterproof clothing, and actually it was developed by a restoration contractor, Tatley Grund in Seattle, and they're focus was one on high performance because everything's tested to only 25 mile an hour wind driven rain, which is way too low. And the other thing is to make the applicator a champion. You apply the products to the substrate. As soon as you can't see the color of the substrate, you've got it thick enough. So the guy can self-inspect himself, or the foreman walking around, the consultant, they know they have it on thick enough. So it was just so simple that the consultants told me when I was marketing it, saying, this is too simple. We're going to lose our jobs. And I said, no, construction is way more complicated. And then when we met hammer in hand, Sam Hagerman, Tom and I showed up, I think it was an evening presentation and training. He said, guys, listen up. This is what we're using. So really exciting.
Yeah, definitely. Well, in that simplicity of application is can be a really important driver in making projects successful in their performance, but also cost effective. And I think that's one of the themes I know that you all want to share with listeners in this conversation. And that's kind of trends in multifamily passive house construction and how you are seeing this proven out that these projects can be efficient and affordable. So I'm really excited that is something that really resonates for me for obvious reasons. And we're going to start with a first case study of the Second and Delaware project, which is a super interesting project in Kansas City, Missouri.
The honors, if you will, for the largest passive house apartment building in the world always seems to be somewhat up in the air and changing from time to time. But at one time, at least, and perhaps still, Second Delaware was the largest passive house apartment building in the world. 276 units, 330,000 square feet. And being from Kansas City, we're proud to say that we not only have the Chiefs, but we have that. And and of course, the fact that PROSOCO was very much involved with it is also a source of great pride. So I refer to the portable mock-up, which was created, as the mother of all portable mock-ups. For those of you that have seen a bulldozer going down the highway on the back of a truck, that's mounted on what's called a lowboy, heavy-duty trailer for very big, heavy stuff. And so Second Delaware created a mock-up of their precast panel with rough opening, and they loaded it on a lowboy because that's what was required. And it required us to go lease an enormous forklift to get it off. And I don't recall how long how much time it spent here, but it spent quite a lot of time here. And Ron Tatley was all over it, whom you've heard about. Guy Long, also with BEI, a career forensic waterproofing consultant on the East Coast, who was BEI's marketing director until he joined our staff. He was all over it. And I was not hands-on with it, so I can't really recite the details and the iterations. But those are huge passive house rough openings, huge passive house windows in that facility. And we were able to provide a path forward for them to assure passive house air tightness. And although we don't have hurricanes here in Kansas City, we have some extreme thunderstorms. And especially if you're located right next to the Missouri River with about, half mile of open space, bringing all that wind and rain right against your windows. And so that was as much concern as the passive house air tightness. But suffice it to say that collaborating with the project, they've got an airtight and watertight system in place. I'm reminded of one of your events recently. I think you call it Six and Cane. That's for the benefit of those that didn't see that webinar. basically it's your typical, 30,000 population town with an old downtown and the 2 and 3, 4-story buildings, stuck together as they were in the 1890s and such. And this was a very nondescript facade, all brick, and just a few small windows in it, and really no ornamentation or stone insets or really anything. And although we love brick and we love old buildings, I could sort of understand why they decided to completely remove the entire facade so that the first floor, second floor is just open to the street. And they rebuilt that facade. I don't know the proper jargon, but it was a lot of glass. And I'm pretty sure they didn't know that was going to pass Passive House. They did it's apparently the first commercial Passive House retrofit. And my guess is they didn't know they were going to pass it until it was done.
That's right.
Thank you. And that's kind of a high risk operation. And what we've demonstrated with these chambers on a large luxury home sitting up above the San Francisco Bridge, again with enormous winds and wind-driven rain, is that we can reconstruct, we can emulate, we can build a mock-up and show exactly what's going to happen and iterate on it. And unlike a normal test lab where it's basically, give us your 10 grand, we'll test it once, and if you want to change it, give us another 10 grand kind of thing. We can iterate and collaborate in a consultative way, and that I just struck me that 6 and Cane would that sort of situation where you're really kind of hope and a prayer can be de-risked significantly.
Yeah, that de-risking is so important for if we want to see uptake of Passive House more quickly and more broadly. So bringing some certainty to any element of the project that you can is powerful. So that makes a lot of sense.
Much easier to sell an owner on a programmed approach than hey, time and materials, and we'll see what happens.
Yeah, and easier to sleep as a developer for sure. Well, excellent. I know that also you all were involved in the Oaks project in Hamilton, Ontario, and I think there's some interesting storytelling around that, and compartmentalization, as well as like health and airtightness and HVAC.
There's two senses of compartmentalization. One is when you actually seal the individual units off from one another, the individual living units. And another kind of sort of compartmentalization is where you don't do that, but you test sections of the building in lieu of testing the whole building. It's a great thing to do. ASHRAE, the heating, ventilation, air conditioning engineers, have been recommending that, I believe, for decades, at least for quite a long time, and certainly way pre-pandemic. And it allows you to do something with your building, particularly because it's more and more typical with Passive House apartment buildings for the individual living units to have dedicated HVAC, heating, ventilation, air conditioning units. And it's also a benefit because when one goes out, the rest of the building keeps going. And, the person that has the keys on their belt goes down the basement, gets another one and pops it in. It's a great advantage. But that and the Passive House shell, basically, and I've been trying to find an infectious disease person that'll stand up and agree with this, because I know they do. I'll get to my papers here in a minute. Basically, with a Passive House airtight shell, and then compartmentalization with individualized dedicated HVAC units, my understanding is that if you set the dials right, you've essentially created an infectious disease control facility for those occupants. because they can't infect each other unit to unit, and you can isolate the common areas as well. And you know, the HVAC and the infectious disease industry has known that coronavirus type diseases are almost completely transmitted by aerosolized particulates that float in the air. And it's not so much the 5-foot envelope where you're face to face with someone. I mean, how often do you actually get face to face with somebody within a 5-foot space? You're pretty much invading each other's space in that, and you're not likely to do that very much. And that's what you have to do to catch those large droplets. You have to be face to face within a 5. So most of it is aerosolized. You have a completely clean building, air clean building, no virus in it whatsoever. An infected person comes in, remains a few minutes and leaves. Sometime later, an uninfected person comes in, breathes that air, they become infected. It's the suspended aerosolized particles. And the industry and the medical profession has known about this ever since what's called the SARS outbreak of the Hong Kong towers in 2003, where they had coronavirus migrate both vertically and laterally across and up towers. And they couldn't figure out why until it was studied in the intervening years prior to the pandemic, and nothing was done about it. The ASHRAE recommendation to have about 20% what they call outdoor air, a layperson would call fresh air, brought into through the HVA system has been disregarded. Most schools and offices run about 2%, 2.5%, because they want people to breathe and rebreathe that air so that the building owner doesn't have to heat it and cool it. And when the pandemic hit, within these circles, there was a lot of talk, and you saw some of it in the Center for Disease Control, and you saw a lot of it in what ASHRAE published about, hey, we got to start ventilating. Ventilating means bringing in that outdoor air through the HVAC. Bringing it in through leaky walls, as David Boyer has pointed out, is not the way to do it. One, the walls don't always leak, right? You need a pressure differential to get the leaking going. And it creates horizontal flow, which Professor Lee in Hong Kong, who studied the SARS outbreak, says is the worst thing you can have. You need to have that flow from the bottom vent to the top vent, or not quite so good top vent to the bottom vent. But you don't want horizontal because it's obvious, you're spreading it horizontally, and you have pockets of stagnated air loading up with virus. And then when the wind blows through the walls and moves it around, that's not a good thing. And so the objection to increasing outdoor air has been twofold. One, you're going to introduce supposedly too much water vapor and humidity during the warm months. PROSOCO pre-pandemic was running 10% to their credit without even really knowing anything about the ASHRAE standard. But basically out here in farm country, we just have good common sense, that fresh air makes some sense, and we'll spend a little money to do it. When pandemic hit, again, even before I started researching this, they independently bumped it to 30%. They found that did create some humidity problems. They bumped it to 20, which happens to be the ASHRAE recommended target pre-pandemic. And there's a study that's been quoted in 80 subsequent studies since the pandemic that says if you run 20% outdoor air, it has the same effect as vaccinating all of the occupants with respect to the aerosolized particles, which are the main culprit. Yeah. This has been known for decades. Mm-hmm. And, all I did was, I'm a big proponent of when you're handed lemons, make lemonade. So the pandemic hit, and I sure wish I remembered the woman that put a post out about that study, because it came across my email. She's a passive house expert that everyone would recognize in And if she is hearing this, I apologize for not remembering your name right now. But that got me researching. I do have a legal background and a trial lawyer background, environmental law background. And I set me to researching and basically, if you will, uncovered what experts have known for decades, but we're afraid to say because it's going to burden the building owner community with additional expense. Mm-hmm. Well, guess what? In the 2005 NIST air barrier study, they found that office buildings leak 15 times more than the passive house standard. So if we build these buildings to passive house or retrofit them to passive house or get even close, we're going to be saving tons of money.
Right.
That we can then use to bring in additional outdoor air through the HVAC system, which has the effect of diluting and removing, according to the experts, those coronavirus particles. And also the HVAC flows that all the planning is always done on anyway, really don't work if the walls are leaking. It's like having a fire bucket brigade with holes in the buckets. So if you go with a tight building envelope, you're not only creating a fund of money for increased oxygenation, but you are gaining control for the first time over your HVAC flows for a lot of good reasons. I'll finish up here. I published, caused to be published, a paper on this in the International Institute of Building Envelope Consultants, of which we're members, called Building Science Helps Defeat Coronavirus. And then I took a kind of a simplified version of that and published it in a BOMA publication, Building Owners and Managers Association, called The Great Fresh Air Competition, where I point out examples of buildings being built now. The one example running 75% outdoor air and bragging about it for pandemic purposes. No need to go quite that far. But pretty soon, I think you're going, at the last building envelope summer camp, it's called, 400 people gather in Massachusetts at Joe Stiebrick's establishment for about 25 years now. One of the speakers was Allison Bales, a well-known HVAC expert, and he had his CO2 monitor with him. And, you can pick up these for anywhere from $50 to $250 on Amazon. And people are going to figure out, especially these young people, you wear a CO2 monitor, and when the CO2 is up, that means the oxygen is down, which means the outdoor air is down, which means the potential for aggregation of virus particles is up, which means you need to be saying something to that building owner. I'll leave it at that.
Yeah, no, well said. Well said. And not to mention the impact that these low oxygen levels have on just cognition. It's well documented that once we get to 1,500, actually anything over 1,000 parts per million, but certainly 1,500 parts per million, we see really significant declines in our ability to think and to learn. And so these benefits that you're describing that are applied to COVID also apply to, just learning environments when there's not a pandemic.
I'm so glad you mentioned that. Yeah. I'm so glad you mentioned that. I have a statement of this, it's a short paragraph just summarizing this, and I include a line on cognition, and it's that statement, including the line on cognition, that I submitted to ASHRAE. And in connection with that, the White House has tasked ASHRAE with coming up with a standard on fresh air ventilation and control of the spread of disease within 6 months. And so ASHRAE has appointed a committee of 50 of the top experts within ASHRAE to come up with this. And it's a little bit above my pay grade, but somehow I got appointed one of 3 consultants to advise them. Most likely, I imagine they chose me because of the building envelope connection. But I did emphasize in that paragraph the cognition as well. Very important. Here we have our poor students in there at 2% fresh air when they could be doing so much better, and not to mention, money on the table for businessmen with knowledge workers. So
Absolutely. So David and Pat, do you want to add anything on these themes and the idea of compartmentalization and IAQ?
Well, that's the future. I mean, air barriers, we've gotten pretty good as an industry about using products that are responsive to the tools of people being installed that are installing them to render the outside envelope airtight. And the next challenge is what kind of chemistries and how much access do you need to effectively break that building down into individual condition compartments so you can isolate the influence of one occupant from the others. I do think it does command some different chemistry and different application techniques. I do think that I've got it's challenging for me to have some of the blind compartmentalization products carry much credence in my mind, because I tend to want to see the interfaces we're trying to address and to remove any contaminants from those interfaces that might compromise or may yield short-term benefits, but not long-term gains. So we're working right now on systems that utilize compatible but slightly different and simpler chemistries for compartmentalization, but our products are going to be designed to have eyes on, have the workmen actually see the areas that they're trying to segregate one from the other and install it in a proper fashion. So I think compartmentalization is the future, particularly when you've got individual conditioning units, conditioning separate spaces. And it's just, I don't think it's going to be that much of a challenge. People tend to look at compartmentalization as being very difficult to do. But that's the next horizon.
Well, the legalization of marijuana in Washington State has driven a lot of interest in compartmentalization.
Wow, yeah. Wow.
So,
yeah.
Isolating odors and noise is going to be the greatest benefit from compartmentalization, in addition to energy efficiency and health.
Yep.
Well, with all the building going on, using a fluid applied is simple. It works. I got several jobs, grow community. They saw what we were doing and they switched everything to us, because the product off the shelf might be more expensive, but you can put it on faster. Weather's not really an issue. But then once it's on, then you don't have any leaks when you do the blower door test. So it's more expensive to redo a building once, twice, and further. And I keep seeing people keep trying to cheapen it, and they keep shooting themselves in the foot. So the full liquid system is superior to all the other ones out there.
Just a final note, I will kind of credit back to the people at BEI and the company that begat them. It was Tatley Grund, who is a leak investigation and repair contractor in the Pacific Northwest. They developed some of the basic concepts behind the system. We've worked with them and further refined them to have systems totally opaque when they reach the target thickness, to have color-coded steps in each system so you can view in from a distance, determine at what phase of the work they were in. But most importantly, products that responded to the tool of the applicator so that the applicator could easily replicate high-performing results. And that's where some of the systems that we compete with out there, I think, forget the applicator needing to be able to replicate the steps and the means of making those repeatable results. Success in having an impact in air sealing or compartmentalizing buildings is going to boil down to the ability of the applicator to make the results work over and over and over again. And that's always been our focus, will remain our focus as we take on the new challenges with compartmentalization.
Well, gentlemen, this has been a real pleasure to get to sit down with you and do this interview. I'll point listeners also to the May 2022 podcast interview that we conducted. Really, thank you for your work and for sharing these stories with us. Is there anything that you'd like to add before we close up?
If anybody wants, I cover the whole Western U.S., and if anybody wants a presentation or more information, you can call me, email me, give me my contact info. I'll be more than happy to help you out.
And that was the team from PROSOCO, founded in 1939, and it's great family connection there. And I love hearing business origin stories, and such an interesting one that I don't think they set out to be building science experts when they were when his grandfather was transporting formulations of acid.
Yeah, exactly.
Around in the back of a truck,
related to his work in with used cars, and then that turned into this journey into chemistry and building envelopes.
I was fascinated how you got from radiators to cleaning bricks, and then on to COVID, and then eventually cannabis.
It took there was a little cameo there. Yep. But that's getting into that discussion about at the end about compartmentalization and air control. Control comes up, and I think it's interesting hearing someone like these guys talk about air tightness, and they've sort of obviously learned to talk about the value of air tightness, and the word control was mentioned a few times, and I think that's really useful. I find myself using that word a lot when I'm trying to explain why air tightness is a good thing, because we're usually talking about air tightness and ventilation, and it can be quite confusing when people say, well, why do you need air tightness if you want ventilation? The answer to that is control, and that if you have airtight building, you can control the ventilation a lot better. So then compartmentalization is a extension of that, and being able to control in larger buildings the airflow in specific parts of that building, and that reference to COVID and other airborne disease, illness, just looking after people. And I think that was really interesting, the points you made about CO2 and people being aware of that inside buildings. So very fascinating journey. Yeah, I was struck by Paul's bringing up the idea that adequate, superior ventilation with outdoor air, which is what Passive House is all about, is equivalent to vaccinating against something like COVID for the occupants in terms of the delivery of health, and that you, in order to deliver that in a knowable fashion and to do it effectively, you do need control. So you need that air barrier, and I think it was Pat probably who said that having leaky walls is like having a fire bucket brigade with leaky buckets. So you gotta address those walls in order to deliver on indoor air quality.
Yeah, and I've given that analogy recently. Here we've updated our insulation standards, and what it's going to do is people end up just specifying more and more insulation in the roof, because insulating a roof is relatively easy. Mm-hmm. And I've used that exact analogy, that it's like having a holy bucket and just putting more lids on it.
Right.
It doesn't matter how many lids you put on it. You're still not fixing the holes in the sides.
Yeah.
And you get diminishing returns after a certain level of insulation in the roof. So you've really got to fix those all those holes that you're going to have if you don't pay attention to them. Great. I love the idea of a company that started something completely different originally, but found this niche, found that they could provide valuable solutions to problems that they probably didn't know existed when they started out. They were involved in helping people clean bricks from wanting to build houses faster, but have evolved into a pretty amazing company. If you have a look on the PROSOCO website, it's pretty incredible the range of different products that they've got, as well as aside from the ones that we were most familiar with, they've got a bunch of cleaning products and anti graffiti products. But they've also got some incredible resources. I had a quick look at some of the videos and some of the explainers they've got on their website. So they've obviously put a lot into education, which is something that we find quite often with companies that are supplying components into the passive house world. There tends to be a lot of education about how their particular products work, but also why they're important and how they contribute to making buildings better.
Definitely. And I want to encourage folks to check out the previous episode that we recorded with PROSOCO as well, to understand the work that they did to reformulate their products to remove phthalates from them when they, and this was all part of the big living building challenge project, the Bullet Center in Seattle. But they were kind of trailblazers in as a manufacturer responding to the red list from the International Living Future Institute and changing their products and their practice to in response to that. So that's a cool story that you want to check out firsthand in that episode.
It's always a good sign when a company like that has ingredient disclosure as one of their resources on their website. So
good point. Good point.
Check them out. Prosoco.com. We'll put a link to them and previous episodes. You can find them on the Passive House Accelerator website. Awesome. Anything else, Zack?
I don't think so. No, thanks, Matthew, and thanks, PROSOCO.
All right, we will be back again in the feed with our regular episode. So stay tuned to that, and also make sure you sign up for the Passive House Accelerator newsletter, because there's lots of events going on this month and beyond. So we'll look forward to catching you next time on Passive House Podcast.